All right, let's take another look at an example of that centroid and finding the lengths of the segments. So we're given that Rx. So like I said, I like to sketch it out. It gives me the space to draw on it. So I've got Rx with W is my centroid. So this is my 2/3 piece and my 1/3. It tells me the whole thing. So from R all the way to X is 48. And I want to find RW, which is 2/3. So 2/3 times 48. So I can do 2 times 48, which is 96 divided by 3 is 32. So RW is 32. So you can either subtract 48 from 32 or do 1/3 times 48 to get XW, which gives us 16. So this length is 32, this length is 16. And then we're going to do the same thing for QZ. Go this way. We're going to have Q, W, and Z, 2/3, 1/3. So remember from the midpoint, so if Z is my midpoint, so this is the 1/3 line, and from the centroid to the vertex is the 2/3 line. So it tells us that QW is just 30. So 2/3 of this whole line is 30. So how would I find the whole line and how would I find WZ? Well, think about 2/3 and 1/3. How do I go from 1/3 to 2/3? I take that 1/3 and multiply by 2. So if I want to go backwards, I divide by 2. So 30 over 2 is 15. That means WZ is 15. And the whole length then would be 45 if you add those together. Now when we're graphing our centroids, we have a few things that we can do. You could actually graph it and graph out the medians and find the midpoints, but the centroid is very nice to us. It actually has a formula. It's similar to the midpoint formula, but instead of dividing by 2, we're using 3 different points, so we're going to divide by 3. So we take all your x values and multiply them together. Or I'm sorry, add them together and divide by 3. You take all your y values, add them together, and then divide by 3. And that will give you the point or location of the centroid. So we've got 2, this little typo, it should be parentheses, 2 plus 4 plus 6 over 3, and 5 plus 9 plus 1 over 3. So that gives us 12 over 3 and 15 over 3. So when we simplify and reduce, we've got 4, 5 is the point of our centroid.